We'll now continue our discussion of section 1.7, discussing quadratic equations and the various methods for solving those quadratic equations. In the last section, we discussed factoring, and we discussed taking the square root of both sides to solve the quadratic equation. In this section, we will look at solving a quadratic equation using completing the square and also the quadratic formula. So let's begin with completing the square. We're just going to look very quickly at this procedure table, but it is much easier to understand as we work an example. So step one basically says to take your C value, which is the number part of the quadratic equation, the part that does not sit attached to an x, and move it to the right side of the equation. It then says to divide by a if a is not equal to 1. So that's saying that the number in front of your x squared has to be a 1 in order for you completing the square to work. The third step is to divide the coefficient of the x, so the number that sits in front of the x, divide it by 2, square the result, and add this to both sides of the equation. And then step 4 says that you should be able to factor what is on the left side of the equation and then solve. Okay, and again, those are pretty mathematical steps, and it will be easier if we look at it with an example. So let's begin with an example that looks like x squared minus 2x minus 6 is equal to 0, and we want to solve it by completing the square. So remember, step 1 is to take the number part of the equation, the number that sits by itself, the C value, and move it to the other side. So I'm going to do that by adding 6 to both sides of this equation. So we'll have x squared minus 2x is equal to 6. And then it says to check and make sure that the coefficient in front of your x squared is a 1, which it is, so we're good there. And then we're going to take, and I'm going to do this off to the side somewhere, we're going to take the coefficient in front of the x, which is a negative 2. And we're going to divide that by 2, or some books will say that you multiply it by a half. Right, same thing, we're going to divide by 2, and we're going to square the result. So negative 2 divided by 2 is negative 1, and negative 1 squared, negative 1 times negative 1 is positive 1. And that result is going to get added to both sides of the equation. Now, what we have on the left should factor. It should factor into two parentheses that are exactly the same. So that helps us do the factoring. We know that to make an x squared, we've got to have an x and an x. And we know to make this 1 that we have to do 1 times 1. And we know that those middle terms need to combine to give me a negative 2. So the only way to do that is to put a negative and a negative. Remember, it has to be, this first parenthesis has to be exactly the same as the second parenthesis. So you don't have the option of doing one negative and one positive. You either have to do both positives or both negatives. And in this case, because we need to combine to make the negative 2, they both need to be negatives. So now we have x minus 1 squared is equal to 7. And we then solve it using the square root method that we learned in the last presentation. So we're going to come in and we're going to take the square root of both sides of that expression. And so remember, the square root of x minus 1 squared just is x minus 1. The square root of 7 is plus or minus the square root of 7, and I can't really do much with that. And then we're solving for x, so we're going to add 1 to both sides. And so we end up with x is equal to 1 plus or minus the square root of 7. And again, we want to remember that that is two solutions, one with a plus in the middle and one with a minus in the middle. Okay, so let's take a look at part B. Note that in part B, it is set up a little better in that the 2 has already been moved to the right-hand side. The problem reads 9x squared plus 3x equals 2. So we're done with step 1. Step 2 says to check and make sure that the number in front of the x squared is a positive 1. And so it's not in this case, and so we need to deal with that next. So we are going to divide every term by 9, which is going to produce a 1 in front of that x squared. All right, so now we'll have x squared plus, and I'm going to go ahead and reduce this. 3 over 9 is going to reduce to a third. So let's just write it, x over 3 is equal to 2/9. All right, so now we're ready. I think I am going to stick the 1 there. Now we are ready to complete the square. So remember that completing the square means that we're going to take that middle coefficient, so the 1/3, we're going to divide it by 2, and we're going to square the result. So how do we do that? How do we do 1/3 divided by 2? Remember that the 2 is over a 1, and we can't really divide fractions, so instead we multiply by the reciprocal. So 1/3 times 1/2 is going to give you 1/6. And 1/6 squared, 1 times 1 is 1, 6 times 6 is 36. So we are going to add to both sides of this problem 1 over 36. So let's see if I kind of squeeze it in right here. 1 over 36 plus 1 over 36. Okay. So now we should be able to factor the left-hand side into 2 sets of parentheses. To make it x squared, it's going to have to be an x and an x. Now, think about how you're going to make 1 over 36. Using the same numbers. So you can't do 1/4 times 1/9 because those are 2 different numbers. It's got to be the same number twice. So the only way to make 36 is 6 times 6 using the same number. So we're going to do 1 over 6 and 1 over 6 to make 1 over 36. Again, your signs have to be the same because these parentheses have to be identical. So they've either both got to be plus or they've both got to be minus. There's only pluses in our problem, so I'm just going to use the plus there as well. Okay, and then we need to add 2/9 and 1/36. All right, so I am going to come over here for a minute. I need to add these 2 fractions together. They're going to need a common denominator. If I look at 2 over 9 and write it as a fraction over 36, 9 times 4 makes 36, so 2 times 4 makes 8. So we have 8 over 36 and 1 over 36. Added together gives me 9 over 36, which reduces to a 4th. So let's kind of clean this up. So x plus 1/6 squared equals 1 over 4. And then we're ready to take the square root of both sides. And so we will square root both sides of that problem. And so that's going to give me, let's come over here with it, that's going to give me x plus 1/6 equals plus or minus. Okay, so you take the square root of 1, you get 1. You take the square root of the 4, you get 2. And so then we're going to subtract the 1/6 from both sides. All right, and again, we may need to go off to the side somewhere and deal with that subtraction if we don't want to just use our calculator. 1/2, if we want to write it with a denominator of 6, it's going to be 2 times 3 and 1 times 3. So we have 3/6 minus 1/6 is going to be 2/6. Okay, so hold on just a second here. All right, so let's do this. Let's come in and let's make this have the same denominator first. So we said 1/2 was the same thing as 3 over 6. So I'm going to fix that real quick, and then let's look at what we've got, because I've got to be careful with that plus or minus. So it can go either way. So if it is a positive, 3/6 minus 1/6 is going to give me 2/6. So that's one solution. Obviously, that one reduces to a third. If, on the other hand, we had used the negative, so negative 3/6 minus 1/6, that's going to be negative 4/6, which is going to be negative 2/3, and that will be our other solution. So we have 1/3 and we have negative 2/3 as our solutions. So you can see that in terms of the difficulty, when we get with the fractions, it becomes much more complicated and involved to work out a completed the square problem. You do have to be careful because it gets a little tedious there. Okay, so let's go ahead and look at quadratic formula. All right, so this is our last method for solving a quadratic equation. We're hopefully all familiar with quadratic formula. We know that the formula is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. We also have on this slide that the b squared minus 4ac, which is the part that sits here under the radical, is called the discriminant, and we can use the discriminant to tell us how many solutions we expect to have from a problem and what those solutions are going to look like. And so in general, on our discriminant, if your discriminant is a positive number, okay, so your discriminant is positive, then you expect to have two solutions that are real, and they're always different. If your discriminant is equal to 0, you expect to have one real solution that's a double root or has a multiplicity of 2, and we saw an example like that previously. And if your discriminant is negative, less than 0, you expect to have two answers that are complex. That means that they have an imaginary I in them, and these are complex conjugates. So they are conjugates of each other, and we'll look at some examples of that in just a minute. All right, so part A of our example says to solve 8x squared minus 4x is equal to 1 using the quadratic formula. So students will find, first of all, that it is helpful to get it set equal to 0. So that's going to be the first thing that I'm going to do here is move that 1 over. 8x squared minus 4x minus 1 is equal to 0. Now, if you're beginning with this or you find that you make a lot of careless mistakes in math, it is often a good idea to write down what your A is, what your B is, and what your C is before you get started. Remember, the format is ax squared plus bx plus c. So the A sits in front of the x squared, it's going to be 8. The B sits in front of the x, it'll be negative 4, and the signs will go with it. And the C sits by itself, and that'll be negative 1. All right, and then you can plug into your quadratic formula. So I'm going to write the formula down. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2 times a. All right, so what we're going to do here is we're just going to go through and plug these numbers in the correct spots. So for the a value, we're going to put in 8. So I'm going to put in an 8 in both of these two places here. For the b value, we're going to put a negative 4. So for the b's, I'm going to put negative 4. And for the c value, I'm going to put a negative 1. So we have negative 4, which makes a positive 4, plus or minus negative 4 squared. Negative 4 times negative 4 is a positive 16. Then we have minus 4 times 8 times a negative 1. That's a positive 32. 2 times 8 on the bottom is 16. So we have 4 plus or minus, adding 16 and 32 makes 48 over 16. All right, let's look at what simplifying we can do. That 48 can be written as 16 times 3. Sorry, let me get back to where we were. There we go. All right, so 16 times 3 for the 48. Now, we can take the square root of the 16. So the square root of the 16 is going to be 4. That's going to come out outside. We cannot take the square root of the 3, so we'll leave that underneath. And we're going to keep the 16 on the bottom. Now, we can simplify as long as we can simplify all 3 of these positions. So they are all divisible by 4. So 4 goes into 4 once, 4 goes into 4 once, 4 goes into 16 4 times. And so we end up with a solution of, write it up here, 1 plus or minus the square root of 3. I'm going to leave out that 1 in front of the square root of 3 over 4. All right, it is 2 solutions. They are 2 different solutions, and we knew that as soon as we saw that our discriminant was positive. We have 1 minus the square root of 3 over 4 and 1 plus the square root of 3 over 4. All right, let's try another one. So this one is set up correctly. T squared plus 6t plus 13. So in this one, the a value is 1. That sits in front of the t squared. The b value is 6, and the c value is 13. And so if we go to plug in our quadratic formula, remember that our quadratic formula looks like this. So we're going to put in negative b, so that's going to be negative 6. B squared is going to be 6 squared minus 4 times a times c. So 1 times 13 over 2 times a, so 2 times 1. Simplifying underneath the square root, 6 squared is 36. 4 times 13 is 52. And 2 times 1 on the bottom is 2. So we have negative 6 plus or minus the square root of negative 16 over 2. So right now, what do we know about the number of solutions? Since the discriminant is negative 16, we know that we're going to have 2 answers, but that those answers will both have an I in them. Okay, we're not going to have any real number answers, but we will have 2 solutions that are complex numbers. All right, so let's finish this thing up. What is the square root of negative 16? The square root of 16 is 4. And because it is a negative, we're going to put an I on that. All right, and again, we can simplify this as long as we can divide into all 3 of those positions. They are all divisible by 2. 2 goes into 2 once, 2 goes into 6 3 times, 2 goes into 4 twice. And so our final answer will look like x is equal to, or actually t in this case, t is equal to negative 3 plus or minus 2i. Now, we do want to take just a quick look at the discriminant. Sometimes we're asked just to determine what is the discriminant and then talk about the number of solutions. So let's just kind of walk through that very quickly and be sure that we understand that. Remember that the discriminant is just the b squared minus 4ac part of the problem. So like in part A here, b squared, the b value is going to be 12. So we would have 12 squared minus 4 times a. A is, right, negative 2, and c is negative 18. So I have 144 minus 4 times 2 times 18. That's also going to be 144. So we get 0. So if the discriminant is 0, we know that there is 1 real solution. Okay, and we're going back to know that. We're going back to this chart. If it's equal to 0, we have 1 real solution. All right, so that's part A. All right, let's look at part B. Same thing, we're going to plug in b squared. So b is the 7 minus 4 times the A, which is 5, times 2, which is the C. So we have 49 minus 4 times 5 times 2 is 40. And so we get a positive number 9. So remember that if your discriminant is positive 9, you have two distinct real solutions. And then our last one, the B value is negative 4. So we're going to have negative 4 squared minus 4 times A. A is 1. C is 9. So negative 4 squared is 16. 4 times 1 times 9 is 36. And so we're going to end up with a negative number here. We're going to end up with negative 20. Remember that if we have a negative number, we have two solutions, but they are complex solutions. Meaning that they have the I in them. And those two complex solutions are conjugates of each other.